Okay, this video is about exponent rules. Bear with me, there's a lot of them, but they're important for us to learn, so here we go. Alright, the first rule is you have a base. If you multiply the same base by the same base, like this x by this x, you add the exponents. So you add. So when you have x to the fifth times x to the third, you get x to the eighth. Piece of cake, right? It works the same way with rational exponents or fractions. So you just do 1/4 added to 3/7. You need to get common denominators, which is 28. So 4 times 7 gives me 28. So you do 7 times 1, 7 over 28. 7 times 4, you do 4 times 3, that gives you the 12. And then you add the top and you leave the bottom. This is adding fractions. I taught you guys how to do it in your calculator. That's a fine way to do it. You should know how to do it by hand, though. Let's call it that. All right. Second rule. When you have the same base, you subtract the exponents. All right. So, you know what this is saying? X to the fifth power is saying there's 5 x's on top, and there's 3 x's on the bottom. This is another way to do it. Why this works is because you cancel these x's. Bye-bye, bye-bye, bye-bye. You're left with 2 on top. So the rule that always works is you do 5 subtract 3, or the top subtract the bottom. See, back here. M minus n, top exponent minus the bottom exponent. Great, next rule. Oh, actually, I just did a fraction because we have to do rational exponents. Rational just means fraction, right? That word rational, ratio. Rational exponents, ratio, fraction. So this is just subtracting fractions. You get common denominators, you get 1/4. There you go. This is a negative exponents. Well, you should always write negative exponents as positive exponents. And so the way you do this is you put it into the denominator. If the negative exponent is in the numerator, you put the base into the denominator and make the exponent positive. Alright, so here's one. 5 to the negative 1. You just put the 5 down in the bottom and you make that negative 1 a positive 1. You know, you don't really ever write that little 1, but I'll write it just because you guys should know it's there. But it's like a thing that's assumed in math. So if you have this example, x to the negative 3, you just write it 1 over x to the third. Here's an example with a number, 2 to the negative 3. So you put the whole thing into the denominator, and the exponent becomes positive. All right. X to the 0 power. By definition, this is 1. My best reasoning behind this is it's like how our number systems works. If you understand now that this is 10 to the negative 2 means 1 over 10 squared, and 10 squared is 100. 10 to the negative 1 is 1 over 10 to the first power. We could even go here and do 10 to the negative 3. And that's 1 over 10 cubed, which is 1,000. You know, you just add on that 3 zeros, right? All right. Well, then, so that these are really little numbers. Small numbers getting bigger. 1/10 is getting bigger. And then you're at 1. So this kind of holds the place value of our numbers. And then 10 to the first power is 10, 100, 1,000. 1,000. Let's write that correctly. Hey. All right. Then, so I put some examples. 5 to the 0 power is 1. 127 to the 0 power is also 1. Anything to the 0 power is defined as 1. All right, moving on. This is a power to a power. The rule is you multiply. Why? So 3 times 2 is 6. Because really you're writing this twice. And if you go back to the very first rule, then you went, so the first rule and the fifth rule have a lot in common. So what you do is you add these 3. 3 plus 3 is 6. If you remember, when you multiply x's, you add their exponents. Okay. Next. X to the third to the fourth power. You get x to the 12th. So you could write it all out, or you can just learn the rule. 3 times 4 is 12. But the rule works because x cubed, x cubed, x cubed, x cubed. X cubed 4 times gives you x12. Okay, and we got to do it with fractions. Fractions are really easy to multiply, though. You just multiply the top. 1 times 2 is 2, and 5 times 7. Let's do another fraction one. X to the 1/2 times 3/5. That would be x to the 3/10. All right, moving on. Good job. Hang in there. Here's a big one. Okay, 64, x to the 2/5, y to the third. All of that junk to the 1/3 power. So here's what you have to do. You have to do every part to the 1/3 power. You have to do 64 to the 1/3. You have to do x to the 1/3, and then you just multiply 2/5 times 1/3. And then you have to do y. It was y cubed to the 1/3. So your answer, 64 to the 1/3, is like you think backwards. 4 times 4 times 4 is 64. And then you just multiply 2 times 1 and 5 times 3, 15. And then when you do this one, 3 is like 3/1 times 1/3. These just cancel to be y to the 3/3, which is y1. Y to the first power. But you don't really ever put first power, right? Because that's like just assumed. We're smart and we know that. Okay. 2 things multiplied to the power. You have to do both parts to the power. So here's an example. You do 2 cubed and then you do n cubed. 2 cubes 8, n cubes n cubed. Same thing. 7x cubed, 7 cubed, x cubed. Rule 7. It's a fraction and you do it to the power. Means you do both top and bottom to the power. So here's the example. 1 squared, 3 squared. 1 squared's 1 and 3 squared's 9. So if you have 2a over 3b, you square the 2 and get 4 and a squared. And then you square the 3. So here's the work for it. Square to get 9 and b squared. Okay. This is a rational exponent, and this is how you rewrite it to a radical. You always put the index on the bottom. N in this case is the index. Sometimes we say what is inside over outside. Inside over outside. All right. Outside meaning the index. This is called the index. In a square root, it's always a 2 there. Remember that? But you don't really ever write the 2. But you think, oh yeah, square root means 2. Because like a cube root of 8, that's 2. The answer is 2. But it means what times what times what is 8. A cube root, for anything besides a square root, you have to write the little number there. Okay, this is just like rule 8, but with numbers. So, here's my example. Again, the top thing goes inside the radical, and the r is the index in this case. So 27 to the 2/3. You can solve it either way. You can do 27 squared and get 729 and then do that to the 1/3. Or you could split it up like this, 1/3 times 2. 27 to the 1/3 and get 3 and then do 3 squared is 9. I think this way is easier. But so it's just kind of 2 ways to do the same example. You can do it this top way or the bottom way. I guess they're the same example. So I don't write, that's another example. Alright, that's the exponent rules. Study them, learn them. We have lots of problems to practice. Alright, good luck guys.